All right, good morning. We're going to look at rewriting a quadratic function into standard form. So this is one of your assignments with Delta Math. So we are just going to look at this part right there. So we're going to start by doing the box method. So I have x and negative 2 at the top, x and negative 5 at the bottom or on the side. And then I'm just going to multiply. So x times x is x squared. X times 5, negative 5 is negative 5x. Then negative 2 times x is negative 2x. Negative 2 times negative 5 is 10. So then if I look, those terms are the same. They are x terms. So I'm going to put those together. So I have x squared minus 7x plus 10. And then I have to bring that 5 down. So I still have the 5 out front. So I'm going to multiply that. I'm going to use the box method again. Put the 5 out front, so that's 5x squared minus 7, or 35x, my bad. Oh, let's try that again. So I had x squared, negative 7x, and 10. 5 over here. So remember, when we're talking about standard form, that's where we had ax squared plus bx plus c, where a, b, and c are all numbers. So I can put this in here. It's going to be 5x squared minus 35x plus 50. This is 5 is A, negative 35 is B, and 50 is C. So let's take a look at graphing this one. So I'm going to show you the method the other day we went through how to do it and calculate it. We're going to do it on Desmos. So, uh-oh. I have x. I don't know why I keep having to do that. X squared minus 10x plus 16. I have no idea what's doing this, but got to get it in so you guys can see. Okay, so when I do that, I'm just going to zoom out so I can see. And then if I start pressing on the graph, I can see what's going on. So it will give me the vertex, which is right there. It'll give me my zeros or my roots, x-intercepts, which are there. And then you just need 2 more sets of points. So look where you can find it cross and find a set of points that go with it. So, for instance, it crosses up here. You can go up and down the line with a dot. If you can see, I found an exact 3, -5. If I go over here, I have the same thing. 7, -5. So now you can graph all 4 of those points. You have 2, 0, 8, 0, 3, -5, and 7, -5. And you just put those on there, and that's how you graph that. Okay, so the last one was calculate the relative extrema. So what I want you to remember, and you probably won't, so let me give you the formula. In order to find the vertex, which is where the relative extrema is, it's -b over 2a. So this is important once again. So a goes with the x squared term, b goes with the x term, and c goes with the number by itself. So I'm just going to plug that in. So this is a negative already. So it's positive 2.7 divided by 2 times a negative 0.7. And that's going to give you your vertex when you do it. You're going to need a calculator. And I am not going to pull Desmos back up on the screen because it's acting funny, but I'm going to do it on my phone. So that's negative 1.92. It's actually 928. So real quick lesson. It says round to the 100 spot. The 100 spot is right here. So what I do is look at the next number. So I look at this one. If it's 5 and above, I round this one up. If it's 4 and below, it stays the same. So this would be negative 1.93. And then what I have to do is I'm going to use Desmos, and I am going to take out the x and put negative 1.93 in. And solve. So I have the x value. I'm putting the x value in. So you're going to do this on Desmos. Put it in with the parentheses. Make sure you put the negative sign in because it will make a difference. All right, when I solve that, I get 10.562. So once again, I have to round to the 100 spot, which is a 6. So I am looking at the 2. The 2 is below 5, or 4 below, so the 6 stays the same. So it's 10.56. So my answer here is going to be the coordinate, which is this value that we just calculated. So negative 1.93 and then 10.56. I know you're going to get frustrated on this if you don't round correctly. So remember the steps, you use your negative b over 2a, and then you take what you get and you plug it back in for